Let's take a look at this cubic functions question. Question 8 reads, given f of x is equal to x to the power of 3 plus 4x squared minus 7x minus 10, write down the y-intercept of f. Y-intercept, make x 0. If x is 0, y is equal to negative 10, since all of these terms will be 0. So the y-intercept, y is equal to negative 10. Question 8.2. Show that 2 is a root of the equation f of x equals 0. So to solve for this, what we need to do is we need to substitute 2 in our equation. So if we substitute 2, we're going to get 2 to the power of 3 plus 4 times 2 squared minus 7 times 2 minus 10. That means f of 2 is equal to 0. And what this means is it tells us that it is a root. In other words, it is an x-intercept. So one x-intercept is 2 and 0. Question 8.3. Factorize f of x completely. Okay, now what we'll do is we'll factorize it using synthetic division. So let's set up the equation. We are dividing 2 into it, and now we use the coefficients. So 1x cubed, 4x squared, minus 7x minus 10. Then we bring down the 1, and we multiply. 2 times 1 is 2. Now we add. 4 plus 2 is 6. Then multiply again. 2 times 6 is 12. Now we add. Minus 7 plus 12 is plus 5. Now we multiply. 2 times 5 is 10. And 10 minus 10 is 0. Now from here, we're going to get the remaining bracket. So my first bracket is going to be x minus 2. Right, that's my first bracket, because x equals 2 is one of my solutions. And the remainder is going to be 1x squared plus 6x plus 5. Right, and that's my f of x. Now from here we can factorize. We're going to get x minus 2. And then here we're going to get x plus 5. And then x plus 1. And since we're solving for or we're not, so that's f of x. So we factorize it completely. So that's it, factorized. Question 8.4. If it is further given that the coordinates of the turning points are approximately at those points, draw a sketch graph of f and label all intercepts and turning points. Okay, so I'll do that on the new page here. Right, so we have our x and y axis. This is more of a sketch, right? So x-intercept here is 2. The other x-intercept will be minus 1. And then the other one will be minus 5. Then we have a turning point minus 3.4. Minus 3.4 maybe somewhere around here. Up here. And that corresponding y value would be approximately 20.8. And then we have the y-intercept, which we said earlier was negative 10. And we have the other turning point, they tell us is what? 0.7 minus 12.6. So 0.7, one is there, 0.7 probably around here. And minus 12.6, roughly around there. So now we sketch this. Let's sketch this graph. Something like this. Of course, it looks a bit funny, but That's the idea. It's just a sketch. Okay, so we have, I think, most of the information now. All right, let's move on. Use your graph to determine the values of x for which f prime x is less than 0. So what they're asking for here is where is the tangent of the line going to be? The tangent of the line going to be negative. Okay, so what I'll do is I'll color code it. Okay, so here this is a positive slope. Here is also a positive slope. And in this region right here, this is where we're going to get a negative slope. All right, so I'm just gonna tabulate it and you'll see why. So no, actually it's fine. So we want to know where it's going to be negative. It's going to be negative in this green region. So in that green region, so the answer then would be 8.5.1. It's going to be negative between the turning points. The turning points were minus 3.4 and 0.7. And the next question reads 8.5.2, the gradient of a tangent to f will be minimum. So in this question, what they are asking us is they want to know basically what is the point of inflection, right? Now there's two ways of solving the point of inflection. The first way to solve the point of inflection would be maybe just to take the average of the two turning points or take the double derivative. So let's go the double derivative route. So f prime x is going to be 3x squared plus 8x minus 7. That means the second derivative will be 6x plus 8. Now, when the gradient of the tangent will be a minimum, that's when you equate it to 0. So 6x plus 8 is equal to 0. 6x is equal to negative 8. X is equal to minus 1,33. And this turns out to be the x-intercept for this function, for this straight line. And you can see where we use it now. The last question reads, use your graph to determine the values of x for which f prime x multiplied by f double prime x is less than or equal to 0. So what I'm going to do is, this is my function for f of x, right? But I've color coded the f prime x. So the derivative, the tangents, I've color coded them. So the orange region is where it's positive, the green region is where it's negative. Now what we should do is we should do the same thing for double prime. So double prime x, let's plot this. Let's plot it on the line. So the y-intercept is 8, the x-intercept is minus 1,33, and we can draw that line in. Like so. Okay. Now, what we should do next is divide this graph into separate regions. Okay. So one region I'm going to divide is this region here, where x is minus 5. Then we have this other region here, where x is minus 3.4. Then we have the minus 1,33. Then we have the minus 1. Then we have the 0, of course. We have the 0.7. And then we have the 2. Okay. Now I'm gonna use a table method, and you'll see what how I solve this now. So f prime x and then f double prime x, and that needs to be less than or equal to 0. Now how can we get the product being less than or equal to 0? Well, if this is positive and that's negative, or if this is negative and that's positive. Now we've already color coded the f prime x, so let's fill in those colors. So where it's this orange color is where it's positive, and where it says green color is where it's negative. Now let's color code the f double prime x. I'll use blue for where it's negative. So it's negative from here. All right. And then I will use, let's go with yellow. Actually, let's go with pink. Pink for where it's positive. So it's positive from here onward. And now what I'm looking for is I'm looking for regions where I have that color combination, right? So the first color combination I'm looking for is I'm looking for an orange region and a blue region. So orange and blue. Well, orange and blue starts from here. Orange and blue is here. So one solution is going to be when x is less than or equal to minus 3, 4. So that's going to be one solution. Then I'm looking for the other color combination where it's green and purple or green and pink. So green and pink starts from here. Green and pink starts from here, this minus 1,33, and it goes all the way up to here. So green and pink is in this region right here. And that is x must be between minus 1,33 and 0,7. Now, for those of you who prefer to solve this algebraically, not using a graph, let me show you how this works. So first, let's write out our expression. So f prime x multiplied by f double prime x must be less than or equal to 0. Let's substitute our expressions in. So f prime x was 3x squared plus 8x minus 7. So 3x squared plus 8x minus 7, so plus 8x minus 7, and then multiplied by 6x plus 8, and that's less than or equal to 0. Now from here, we treat it like a normal inequality, okay? We factorize this, and once we factorize, we then get critical values, and then we can solve. So the first one, and again, use your calculator. So here I'm using the first expression is going to be 3, 8 minus 7. So this one here is going to be, so my answers here rather, let's just go straight to the answers. These are my critical values rather. So critical values, I'm going to get x is equal to 0.69. Then x is equal to minus 3,36, and that's from these two. And then from this one, I'm going to get 6x plus 8 equals 0, 6x equals negative 8, x equals minus 1,33. So we have these three critical values. Let's input that on our number line. So we take this, put it in our number line. So minus 1,33. Then here minus 3,36, and then here 0,69. Now you'll notice that it's the same values that on our x-axis. So minus 3,3 is roughly 3,4. Then here minus 1,33, minus 1,33, and then here 0,69, and then here 0,7. But the benefit of doing it this way is that it's only focusing on the critical values, the values that are important. Now all we have to do is we need to substitute a value in for x to see whether we get a positive or a negative value. Now, I want to substitute negative 2. Right? If I substitute negative 2, because negative 2 is somewhere in here. If I substitute negative 2 into this expression, this whole thing here, will I get a positive or a negative answer? Let's see. So you have 3 and negative 2 squared plus 8 times negative 2 minus 7. then times 6 into negative 2 plus 8. That gives me a positive answer. So now what we do here is we'll put positive here and we will alternate. Now remember, we wanted values for x where it's going to be less than or equal to 0. So it's going to be negative, you can see here, when x is less than or equal to minus 3,36, or you can see here, when x is between minus 1,33 and 0,69. And you can see here that these values, this answer matches up perfectly with this answer right here. Okay, thanks so much for watching. I hope you found this video useful, and I'll see you in the next one. Bye bye.